Hey there, everyone. So I wanted to do an example using this conservation of momentum formula. Sometimes people get hung up on it. So essentially what we have here is a formula that says the initial total momentum of our system has to be equal to the initial total momentum of our system after a collision. Now, a lot of times students get confused on these, so one thing I recommend that you do if you feel like you're going to struggle on this is to make yourself a list of the values before you try to start plugging things in. So on the left-hand side, I label it initial. On the right-hand side, I label it final. And then I'm going to put mass 1, velocity 1, and then mass 2, velocity 2 down the center. And I'm just going to record the values. For example, like my initial mass number 1 is going to go in that spot right here. And then for final mass 1, it'll go over here. So now I go to the text and I can see right here, my first item is a 13 kilogram ball. So I'm going to have that be item number 1. So its initial mass is going to be 13. And it tells me this ball has a velocity of 3.6 meters per second. So that is going to be its initial velocity. Okay, then it tells me it strikes a 9 kilogram ball that is at rest. So this 9 kilogram ball is my second object. So its mass is 9.0. And since it tells me it is at rest, that means its initial velocity is 0. It is not moving. Okay. After the collision, the 9 kilogram ball has a velocity of 4.2. So the 9 kilogram ball, that was my second mass. So I'm going to put that back down here in red. And its final velocity is 4.2. Okay, and then it asks me, what is the velocity of the other ball after the collision? Now, we are assuming that the mass doesn't change, like the ball doesn't break or anything like that. We're still just one ball, so my mass is still going to be 13. And my final velocity for object number 1 is unknown. Once I get my information kind of separated like this, what you need to recognize is that the values in the left-hand column will all go together on one side of the equation, and the values in the right-hand column will all go together on the other side of the equation. So what this is now going to look like, if I look at my first part of my equation, it says take mass 1 times the velocity 1 initial. So that's going to be these two values right here. So I would have 13 times 3.6. Okay, plus, and then it tells me to take mass 2 times the velocities. So that would be 9.0 times 0. And then for the second part of my equation, I'm going to take my final values. So mass 1 times my final velocity for mass 1. So that is the 13 in the x. Plus, and now I'm going to have my mass 2 and final velocity for mass 2. So 9.0 times 4.2. Once I get all my values into my equation, then I can go ahead and start doing my computations. So on the left-hand side, I'm going to type in 13 times 3.6 plus 9 times 0, which is 0. That left-hand side gives me 46.8. And on the right-hand side, I would have 13x, and then I need to take my 9 times my 4.2, and that gives me a 37.8. At this point, I can just use some basic algebra to solve my equation for x. So I'm going to subtract 37.8 from both sides. Oh, let me change it. And that leaves me with 9.0. And here I have a 13x. And then I'm going to divide both sides by 13, which gives me x is equal to 0.6923, etc. And now I need to go back and look at my significant figures. And it looks like I have 2 significant figures for all of this. So I am going to go to 0.69 meters per second would be the final velocity of that 13 kilogram ball.